Okay, this is a catch-up lecture for MATH6055 for Computer Science 1. This is just the rest of the sets and relations additional notes, and there's just a few small concepts. Now in this particular note, we did a lot of work with the empty set and really stretching your brains inside out so you would really truly understand the difference between an object being an element and a set being a subset. That kind of stuff isn't exactly going to be examinable. Now you do need to be able to list the subsets of a set, and you would, for example, have to list the elements of a Cartesian product, but we probably wouldn't push you too hard in terms of is the set containing the empty set an element or a subset of the power set of a given set. Now this little section, however, is examinable. The Inclusion-Exclusion principle. Now it's just a little formula here which can be said, now these bars here mean the cardinality or the number of elements. The number of elements of in A union B is equal to the number of elements of A plus the number of elements of B minus the number of elements in the intersection. Now we can draw a picture of this just as a little kind of a proof. We just need two sets. We will put it in an ambient universal set that A and B are subsets of. So this larger set here is our ambient set U, and we have two subsets of U, A and B. So here is A and here is B. Now an element of A union B, so that's something that's in A or B, is either in A but not B, B but not A, or A and B. And so if you count elements that are in, if you count the number of elements that are in A plus the number of elements of B, what will happen is you will count the middle twice. So something like this, if you count the elements of A plus the elements of B, you will get the number of elements in A without B plus the number of elements in B without A, but you will count this twice. You'll count it once when you're counting A and a second time when you're counting B, so you'll have plus twice the number of elements in A intersection B. And therefore, to get the number of elements in A union B, which should be number of elements here, plus number of elements here, plus number of elements here, you should subtract one of these. So if you do this, number of elements in A plus number of elements in B minus one of these, that is the same as number of elements in A union B. And you get this identity here. Now this little formula will not be on the tables or anything like that, and it will be examinable. You'll probably know at this stage, because we're only doing it now, it's not going to be examinable on your test, certainly on your final exam in the winter. So the number of elements in A or B is the number of elements in A plus the number of elements of B, and minus, take away once, the double countings. Okay. So we'll do three little examples here. So let R be the set of red playing cards, and P be the picture playing cards, just King, Queen, Jack. Won't include ace. Find the number of elements in R union P. So what we should do here using this formula, we have the number of elements in R union P is equal to the number of elements in R, the number of red cards, plus the number of elements in P, the number of picture cards, take away the number of elements in R intersection picture. Now, R intersection picture is a set of cards that are red and a picture card. So, if we know this for a way, it's not too bad. So we have the number of red cards. Of course, half the cards are red. There's 52 red playing cards, or there's 52 playing cards. So half of them are red. Half of 52 is 26. Picture cards, you've got King, Queen, Jack, 3 in each suit. So 3 by 4 is 12. And take away the number of cards that are red and a picture card. And there's going to be 6 of these. You're going to have King, Queen, Jack of hearts, and King, Queen, Jack of diamonds. So take away 6. Now you can kind of understand this formula with these numbers here. So this 26 red cards includes the 6 red picture cards. These 12 picture cards here also include the 6 red picture cards. So we've counted those red picture cards twice. So that's why we take away. We're banging the numbers. I want to again 26 minus 6, 20, plus 12, 32. So this is kind of what you'd be expected to do. You can of course count this directly, but it'd be pretty difficult. The question might ask you to use the inclusion-exclusion principle, and this is this. Okay. Another example. In a group of 20 smokers and drinkers, 15 said they drank and 7 said they smoked. How many drank and smoked? Now this time we're going to work a little bit different. So these are 20 smokers and drinkers, so you've just got 20 people, that's everybody. So over here you've got drinkers or smokers and drinkers. They don't all smoke, they don't all drink, there's 20 of them all together. That'll be your drinkers or smokers, and the number of these will be equal to the number of drinkers plus the number of smokers minus the number of those who drink and smoke. So here again you'll see the double counting. The total number of people, 20, is comprised of the people who drink and some of them smoke. The people who smoke and some of them drink, so you've counted that twice, so you take them away once. Now we're looking for the number of people who drink and smoke, so this is our little unknown. And now either we put in the numbers now and then solve, or what is actually the clever is to solve at this point. I'm going to add this to both sides, take this away from both sides, and we'll get a different formula, which will obviously be true all the time as well, that the number of elements in A intersect B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A union B. So we have 15 drinkers, 7 smokers, and altogether we have 20 people, so that's 2 of them had to drink and smoke. Now it wouldn't be difficult to figure that out, because you've 15 drinkers and 7 more smokers. Well, if you add that up, there's 22 people, so 2 of them must have done both, and that's kind of in here. So add up all the people, you get 22. Take away the 20, there's 2 left over, 2 of them must have drank and smoked. Now this one is starred. Slightly harder, so it's when you don't have the full information. So here you've got 100 people. Now the difference between this and this, 20 of these people either smoke or drink. They're smokers and drinkers. Here we've got 100 people. We're not necessarily saying that all of them like Coldplay or all of them never saw The Big Lebowski. So the question is, can we say anything about how many people like Coldplay and haven't seen The Big Lebowski? So again, we use set here to set us up. So set C be the set of people who admit to liking Coldplay, and B be the set of people who've never seen The Big Lebowski. It's not true that we've got 100 here. Some people might dislike both. We do know that this is less than or equal to 100 though. So what we can say is something like this. The number of people who have not seen The Big Lebowski or admit to seeing Coldplay, and we're trying to find the number of elements in B intersection C, the number of people who that's a bit wrong. Well, we want to see the people who like Coldplay and haven't seen. So we want to find what the question is basically saying, can we say anything about B haven't seen The Big Lebowski and like Coldplay? So this, using our inclusion-exclusion principle, is number of people who haven't seen The Big Lebowski plus the number of people who
who admit to liking Coldplay take away the number of people, that's what we're interested in, who haven't seen The Big Lebowski and admit to liking Coldplay. And we know that in total, now it starts a slightly harder question, that this, which is the same as this, must be less than or equal to 100. And now we can put in the numbers. We know that 56 people have not seen The Big Lebowski. We know that 70 admit that they like Coldplay. Take away number of elements in B intersection C, less than or equal to 100. And what we can do with an inequality is you can add the same thing to both sides, take away the same thing from both sides, and it will still remain an inequality. So in particular, I can add this to both sides and take away this. And if we do that, we'll find that the number of people who haven't seen The Big Lebowski and admit to liking Coldplay, basically, well, would be, this is 126, would be greater than or equal to 26. Something like that. Now it could be larger. You could put a maximum on it, but that's all we can say.